To demonstrate the current theory of how the loop of Henle forms the medullary osmotic gradient, here's a simplified view of the cortex and medulla. This theory is called the countercurrent theory because of the opposing flow of filtrate within the two limbs of the loop. The complex interplay of the ascending and descending limbs forms and maintains an interstitial osmolarity with a gradient from approximately 1200 milliosmoles near the bottom of the loop to the normal 300 milliosmoles near the cortex. The gradient formed by this activity is essential for the concentration of urine. To demonstrate how the gradient is formed, we will look first at the role of the ascending limb of the loop and then at that of the descending limb, because the ascending limb creates the conditions necessary for the descending limb to function. Click the ascending limb to begin. The ascending limb of the loop actively transports sodium chloride into the interstitium, increasing its concentration while restricting the diffusion of water. The interstitium surrounding the tubule becomes more concentrated, while the fluid inside becomes more dilute. As the fluid moves up the loop, there is progressively less solute to pump out, so the highest concentrations of solutes are near the bottom of the loop. Now click the descending limb to continue the process. The role of the descending limb in this process is to provide a continuous concentrated supply of sodium chloride to the ascending limb. The filtrate concentrates as it moves down the descending limb because water diffuses into the higher osmolarity interstitium created by the ascending limb. The solutes remaining in the tube reach a concentration approximately 4 times higher than normal body fluid. The effect is much like what happens in the Great Salt Lake when water evaporates and salt is left behind. The fluid that is left is very salty. This salty filtrate provides a ready supply of sodium chloride for the ascending limb to maintain the osmotic gradient. Now click the interstitium and watch the combined but asymmetric activities of the two limbs as they build the osmotic gradient. The way the two limbs cooperate to multiply the solute concentration from the normal 300 milliosmoles of the cortex to a level 4 times higher in the medulla is called the countercurrent multiplier mechanism. This mechanism has also diluted the luminal fluid in the ascending limb to an osmolarity of approximately 100 milliosmoles. As a result, water is retained while solutes are removed. This graphic now shows the 200 milliosmole difference between filtrate and interstitium developed by the cells of the thick ascending limb.